So, in this example we observe that n and u are independent random variables, and also by seeing a probability of u greater than t, that is e power minus lambda plus mu t, you can conclude u is a exponential distribution with the parameter lambda plus mu. Now, we move into the next example. Let x be a random variable having binomial distribution with parameters capital N and P, where capital N is a random variable having Poisson distribution with mean lambda. The question is, find the marginal distribution of x, or find the probability mass function of the random variable x. Given n is Poisson distribution with the parameter lambda, that means the probability mass function for the random variable n is e power minus lambda, lambda power n divided by n factorial. The possible values of n are 0, 1, 2 and so on. Our interest is to find out what is the probability mass function of the random variable x. That is same as n is equal to 0 to infinity. What is the conditional probability of random variable x takes a value k, given the other random variable n takes a value small n, multiplied by probability of n takes a value n. That is same as the n takes a value from k to infinity, n factorial divided by k factorial into n minus k factorial, and p power k 1 minus p power n minus k, multiplied by lambda power n e power minus lambda divided by n factorial. So, no need of n is equal to 0 to k minus 1, because the capital N takes a value small n, therefore, the running index from k to infinity. That is same as you can take some terms outside, that is lambda power k e power minus lambda p power k divided by k factorial. The remaining terms, that is n is running from k to infinity, this can be written in the form of lambda times 1 minus p power n minus k divided by n minus k factorial. That is same as lambda p power k multiplied by e power minus lambda by k factorial. The summation n is equal to k to infinity and so on, that becomes e power lambda times 1 minus p. Therefore, further you can simplify. Therefore, the probability of x takes the value k is same as lambda p power k e power minus lambda p divided by k factorial, where k takes the value 0, 1, 2 and so on. Hence, the conclusion is the random variable x, which is Poisson distributed with the parameter lambda times p. So, this problem occurs in many situations of stochastic modeling. Therefore, we have discussed this example in this lecture.